Okay, so what she was saying here is, sorry, Fermi, you've got to consider all of these lighter elements as well as possibly forming as a result of neutron bombardment. Hello again, everybody. Professor Davis here from chemsurvival.com, YouTube channel Chem Survival. And we're going to continue our discussions for Women's History Month on the topic of women who changed the periodic table, or women who helped to shape the periodic table. And our famous female chemist today is none other than Ida Noddack. Now, you may not have heard of her before. She's not quite as famous, doesn't quite have the star power of people like Marie Curie or Madame Lavoisier. But her contributions to our understanding of the elements and the periodic table is very difficult to overstate. So I want to spend a little bit of time getting to know Ida Noddack and her contributions to our understanding of the elements. So Ida Noddack got her start in science as Ida Tack, her maiden name, earning a doctorate in 1921 in Berlin. And within just a few years of finishing that PhD, she already had published work that would seal her position in the echelons of chemistry forever. And that would be her discovery, or her putative discovery, of two elements, alongside the man who would be her husband, Walter Noddack. Now, this was published in 1925. And as you can see here, she's still operating under her maiden name at that time. Now, the idea that Ida and Walter had was that many elements that are relatively close to positions 43 and 75 on the periodic table could be obtained from platinum ores. And so they believed, well, since those missing elements on the table are adjacent to this group, perhaps we can get them from platinum ores as well. And so they attempted to do this, to acquire both elements 43 and 75 by extracting them from platinum ores. And as evidence, they offered some X-ray data and the names mesurium for element 43 and rhenium for element 75. Now, those are both hovering over here, right over my shoulder, 43 and 75. But you may notice that element 43 is not called mesurium. Element 43 is called technetium. And that is because, although they were indeed successful in isolating and characterizing rhenium, it was later shown that they were simply working with mixtures of other elements with what they thought was element number 43. And so they were partially successful. And so Ida Noddack certainly has left her mark on this column of the periodic table, in the sense that not only did she discover rhenium, but she also thought she had discovered mesurium, a mistake that quite a few chemists actually made in trying to find this element. Okay, but there's another very interesting contribution that Ida Noddack made to our understanding of atoms and the elements. And that is that she is generally considered to be the first scientist ever to propose the concept of nuclear fission, right, in a publication. And this was done in 1934 in an article published in Angewandte Chemie. And in this article, she's actually discussing Enrico Fermi's contention that he has succeeded in synthesizing element 93. And he did so using neutron bombardment of uranium. But Ida's paper is critical of his technique. Specifically, she's criticizing him here because she says, look, you're suggesting that the only elements you have to rule out to prove that decay hasn't happened are those elements down to and including lead. And that's because typically, just common radiation, things like beta particles and alpha particles being shed, cause these heavier elements like uranium and others to undergo a process of incremental decay, leading to usually a stable isotope of lead. And Fermi made the supposition that there couldn't possibly be anything smaller than lead that would form during this process. And since he didn't see any elements between lead and uranium, his new element must be the heavier element number 93. And so, again, she was basically saying, listen, Fermi, you're only looking for these elements as possible byproducts of this process of neutron bombardment, but you've got to consider more. And what she offers as a suggestion here is that you can actually crack the core of a nucleus with a neutron, and that neutron bombardment may not only result in neutron absorption, but also in the cracking in half or into two large pieces of a nucleus. And if that happened, the products would not be close neighbors to the parent atom. Okay, so what she was saying here is, sorry, Fermi, you've got to consider all of these lighter elements as well as possibly forming as a result of neutron bombardment. And it turns out that she was right. So why don't we typically credit Ida Noddack with the discovery or being the first to propose nuclear fission? Well, that's a difficult question to answer. Now, the reason I think that Noddack probably didn't get full recognition for this, of course, the easy explanation would be to say, well, she was a woman. It was the 1930s, and people just didn't take her seriously in the field. But you've got to remember that nuclear physics was a field that had some really heavy hitter female scientists already. People like Marie Curie had already awoken, if you will, male scientists in this field to the fact that women had a lot to contribute. And so, what other historians believe is that the reason Ida Noddack generally was overlooked at this point was that her insistence that she had indeed discovered element 43, a 10-year-long campaign to convince the scientific community that she had actually discovered element 43, when in fact it was quite clear she had not, may have led to a little bit of a dent in her credibility. Now, whatever the reasons are for that, it's pretty clear that Ida Noddack, through helping to discover rhenium and genuinely being the first scientist in print to propose the concept of nuclear fission, certainly deserves a nod as one of those female scientists who helped to shape the periodic table today. Well, thanks for watching, everybody. I appreciate your attention and your time. I'll see you for our next video on another great female chemist who helped shape the periodic table. In the meantime, that's all for now. I'm Professor Davis from chemsurvival.com, and the YouTube channel Chem Survival. See you next time.